Hello, 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 hello. Welcome back. Today we're going to do some more programming with Gemini. Let's see. I watched back like the part of the previous stream, the previous programming stream, and because I had a weird feeling that something wasn't entirely right. And yep. For that whole stream, I forgot to enable guided learning. And I swear, like the whole stream, I thought something was a bit off with like the answers it gave us. Just a tiny bit off. And lo and behold, forgotten to enable that setting because apparently that isn't locked to like a chat conversation for some reason. I don't know why, but that's how it is, I suppose. So we need to make sure that this is always enabled when doing the guided learning stuff. And also, I've gotten a new conversation started here because I think the context length got a bit too much for it to handle accurately, but it might as well also have been like the switch between a guided learning approach in the beginning, like the first stream we did with Gemini, and then a non-guided learning approach. That might have messed up the answers a bit, but here we are with a fresh context anyways. So everything we've done here should be accurately translated for it, hopefully. I guess we'll see. Wait a second. I'm just gonna try something. There we are, and I'm back. Just wanted to make sure that I had my backup chat display open, just in case. There's still some issues with my chat overlay, so yeah, I'm gonna have to look into that tomorrow probably. Because for some reason Kik is duplicating the messages, I don't know why. It's weird, and it's only on the first message as well. Well, enough about that. Let's see. Okay, so I passed along all the context, all the relevant context at least, and here it says context receive. I have your master file loaded in my mind. We have a working, albeit simple diagram model. Let's pick up right where we left off. Topic 33, the hidden dimension, embeddings. Currently your token embedding table is doing double duty. It looks up the token. It immediately provides the probabilities for the next token, because its size is vocabulary size times vocabulary size. To build a transformer, on the other hand, we need to separate these two jobs. We want to represent the token as a feature vector first, the embedding, and then calculate predictions from that vector. We're going to introduce a variable nembed, number of embedding dimensions, embed dimension, okay, and number of embedding dimensions. Let's say number of embedding dimensions equals 32. Okay, concept check. So now we're back to getting like some actual questions about all of this, which is good, since that was the missing link in the last stream. So, before we touch the code, let's trace the shapes to make sure the flow makes sense. If we want to map our input characters to a hidden feature space, and then map that feature space to our output predictions, What should the new shape of token embedding table be? What should the input and output shapes for the new LM head linear layer be for the new, okay. All good questions. If we want to map our input characters to a hidden feature space, and then map that feature space to our output predictions, what should a new shape of token embedding table be? Are we talking about this one here? I'm a bit confused if this is like related to each other at all, or here it says we're going to introduce a variable number of embedding dimensions. I'm guessing we can have multiple. Is it that we can have multiple embedding layers, or is it that we can have more dimensions to one layer? It has to be like the number of dimensions in the embedding layer singular. But can we really have 32 dimensions in one layer? I'm just trying to wrap my mind around having 32 dimensions. Like the math table, and that's, oh my god, I don't even know how to do that. Like stepping above 3 dimensions is a mindfuck, but 32? Nah man, I don't know. This is a good question though. Since I'm very unsure, let's say that we don't know. I'm honestly not sure. This should hopefully give us a better or more firm grounding in whatever's coming next. No problem. This is the most abstract part of the architecture. Seems like every part is the most abstract part, but okay. So it is normal to feel a bit lost at first. Let's break it down by visualizing the data flowing through the model. Step 1, the embedding table. Think of the token embedding table as a literal lookup table or a dictionary. Okay. Literal lookup table. What could it have been, like figurative or what? Literal lookup table or a dictionary. Let's think of it as a dictionary. We give it an index, for example, number 5 representing the letter E. Output, it gives us a list of numbers, a vector specifically for E. Alright. I guess that makes sense. In our old model, we looked up E and immediately got predictions for the next character, size, vocab size. In our new model, we want to look up E and get a feature vector of size n embed or number of embedding dimensions, which we set to 32. Okay, so that's relevant then. This vector represents the essence of E, before we try to make any predictions. Okay. If we have vocab size, total characters to look up, and each lookup needs to return a vector of size and embed dimension, nembed. What should the dimensions, rows and columns of the token embedding table be? Oh my god. It's only been like... Oh wait, it hasn't been only 2 days. It's been way longer. It's been 4 days. And it feels like in those 4 days, a lot of knowledge has left my mind. It's like on the tip of my tongue. On the edge of my brain. Like my immediate instinctual response would be to have what exactly? Columns 32 and rows, I don't know, either like 1 or vocab size, but maybe neither of them either. I don't know. Let's guess rows. Let's guess vocab size. No, let's guess 1 and columns and embed. I just remember us doing like the flattening before, and if that's relevant in any way, I don't know. You're half right. The columns will indeed be an embed 32 in our case. This is because every single character needs a vector of length 32 to represent it. However, let's look at the rows again. Think of this table like a phone book or a dictionary for our characters. If we have vocab size, unique characters, for example 65 distinct letters, numbers, and symbols, and we need a unique entry, a row, for each one of them. How many rows do we need to store a unique vector for every character in our vocabulary? Okay. So I was wrong. Rows, vocab size. I guess that's before us doing any flattening or anything like that. Like this isn't where we actually extract the answer, it's where we're simply creating all the options, like all the classes, whatever we call it. Spot on, you need a specific row for every single character in your vocabulary. So the new token embedding table will have the shape of vocab size and number of embedding dimensions. Oh, so the dimension in this case is how many... how deep the depth is, or how long the column is, or whatever, depending on how you look at it. The 32 number vector for A... Wait, row 0. The 32 number vector for A, row 1, the 32 number vector for B, and so on. Okay. Step 2, the language model head, LM head. Now we have a problem. The embedding table gives us a vector of size 32, number embedding dimensions. But to predict the next character, we need a score for every single character in the alphabet size, vocab size. And that might be larger than the number of dimensions. We need a bridge to translate 32 hidden features back into probabilities for the next character. This is often called the head of the model. We will use a linear layer, nn.linear, for this. Looking at nn.linear in features, out features. In features, what is the size of the data coming into this layer from the embedding table? Out features, what is the size of the prediction score we need to get out? If this is a question, then it's obviously In the in features is obviously the n embedding dimensions, and the out features has to be the vocab size. Let's simply give it the answer and to where am I? vocab size. Clarifying. Wait, was I wrong? No, okay. Excellent, you nailed it. Input, in features, and embed 32. The layer receives the essence of the character. Its vector. Output, out features. Vocab size. The layer projects that essence back onto the list of all possible characters to give us a score for what comes next. This architecture decouples representation, the embedding, from prediction, the head. Okay, so input layer here goes all the way to xn, whatever. And then we have maybe fewer hidden layers, perhaps, and maybe even fewer output layers. No, wait. Hands-on update init. Now let's update the code. We need to modify the init method in the diagram language model to class to reflect this change. Your goal, add and embed as a parameter to init. Default it to 32 if you like, or just pass it in. Change self.token embedding table to use the new dimensions. Create a new layer self-lm-head using nn.linear. Okay. Go ahead and write the new nn method below. It seems a bit confused, so I should ask. Can I write the edit to the diagram language model class inside the master file.py, or should I open a new file? It says like do it below, but I'm not gonna write code in this window, so I'm just gonna make sure that it understands that I'm doing it in a third-party application. Okay, you should edit the master file directly. We're essentially upgrading the entire engine of your existing car rather than buying a new one. By keeping it in one file, you will have complete running model that is smarter with every change we make. Okay. Now it should probably at least remember that I'm not doing it here. So in the init here the self token embedding table, we do want to have another. So add and embed as a parameter to init. Okay, do it here. So n embed, or number of embedding dimensions, and wait, how do we do this? Is it like so? I think that's a default, right? Of integer 32. Can I? Well, it says integer, so I mean, sure. And then let's do an embed. So we have the rows of vocab size and on the embedding table, and the number of embedding dimensions in its columns. And what do we do next? We do create a new layer called lm-head. So self.lm-head equals nn.linear, and we want it to be... pen embed. And out features to be the vocab size, like we just learned. Probably. Is that everything? It should be, I think. Let's paste this here. Wait, paste it up to the diagram language model class here. Let's give it... let's give it everything here. So it has... So it truly has all the context. That looks perfect! You have correctly set up the 2 distinct layers in init. Token embedding table maps character indices to hidden feature vectors. LM head projects those features back to the character probabilities of vocab size. Connect the wires. Now look closely at your forward method. It is still using the old logic. Okay. In our old model, the table outputted predictions, logits directly. In our new model, a token embedding table outputs embeddings, vectors of size 32. Wait, it does that already? I mean, we're still getting the IDX. We're passing this through here, which sets this to be... IDX is a tensor, right? It has to be a tensor. IDX, torch.zeros, yeah, and this is a tensor. Simply one-dimensional, always 0. And that's what we're passing along here. Okay. If we feed these raw embeddings of size 32 directly into cross entropy, which expects predictions for the whole vocabulary, the math won't work correctly. Okay, so if we don't have any targets, we're simply returning the logits as is here. And how does that even look here now? Because when we passed along, when we have the vocab size as the input and output of the token embedding table, then if we passed in a token from the vocabulary, we'd get a token from the vocabulary out. Like if there were 65, if the vocab size was 65, then we'd get one of those 65 out in return, and that's what we get in the logit here. And that would be what we return. But if we only have 32, for example, so to speak, options, then that would mess things up a bit, is my guess. Okay, so the fix, we need to bridge the gap using the LM head layer you just created. Can you update the forward method to store the output of token embedding table as a variable named token embedding instead of logits? That is a good question. Okay, I'm guessing we simply need to update this to token embedding, so the embedding token. Pass that token embedding through your new self-LM head to generate actual logits. Okay, so then we do logits equals self.lm head, and we pass along token embeddings. So we're grabbing the embedding token here, which is going to be over the size. I'm still a bit confused on how this would actually look in practice. Would it be... I guess we can ask. How would the token embedding actually look? Now, before we turn it to logits. That is a fantastic question to ask before writing the code. Visualizing the data shape is half the battle in deep learning. Previously, logits from the table was just scores. Now token embedding represents raw features. Think of token embedding as a 3D block of numbers. So it has dimensions B, T, and C. In PyTorch, we often talk about these 3 dimensions: batch size. B, batch size, how many independent sequences we are processing in parallel, for example 32. Time T time/block size, the length of the text snippet, for example 8 characters. C, channels/embedding size, the size of the feature vector, for example 32. It's a bit confusing when they use 32 and 32, but okay. So if we pass in a batch of data, token embed would look like a 3D tensor of shape 32, 8, 32. Visualizing the lookup. Imagine your input ID X as a 2D grid of simple integers, the character IDs. Before you had a grid where ID X00 is just a number 5 representing E. After, the embedding layer replaces that single E with a list of 32 numbers. The vector for E, it literally inflates the last dimension. Every single character in your text is replaced by its unique feature vector. I think so. I think it's a bit clearer. I'm also battling against like the loss of memory from 4 days ago. I can't speak. The deterioration of the biological mind. There we go. That sentence was surprisingly difficult to pronounce. Okay, so I mean, that's should be all we need to do. Because now we have like the head layer here that's working as a bridge or an intermediary. And converting like the hidden embedding layer size, dimensions, whatever, to back to the vocabulary size. Is the hidden embedding layer always smaller than the vocabulary? What is that? What is that? Or does that vary a lot? That is a really insightful question. It touches on the art of designing neural networks. The short answer is it varies a lot, but there are common patterns depending on the scale of the model. Small models, like ours, in character level models or experiments, and embedding is often smaller than vocab size. Why? We want to compress information if we have 65 characters, but we force the model to represent them using only 32 numbers. The model has to learn which characters are similar. For example, vowels might end up having similar vectors to fit them into that smaller space. Okay. So we're forcing it to compress the data more, which might make it more efficient, but also less accurate, is my guess. Large language models. In modern LLMs like GPT-4, Llama, etc., the vocabulary is huge, often over 50,000 tokens. The trend and embed is typically smaller than the vocabulary size, but it is still quite large in absolute terms. For example, 4,000 or 8,000 dimensions. That's a lot. However, strictly speaking, an embed could be larger than vocab size if you wanted to project data into a super high dimensional space to make it linearly separable. But that is computationally expensive and rare in NLP. Neural linear why can't I say that word? Linear, there we go. Neural linear, oh my god. Neural linear programming is my guess. I don't know. I just had to say that word because for some reason that was a tongue twister. Think of the embedding dimension as the width of the thought pipe. Narrow pipe, small, and embedding dimensions forces the model to abstract and generalize more. Compression. Wide pipe allows the model to memorize more specific details and nuances. With multiple hidden layers. Does it mean like multiple dimensions to hidden layers, or does it mean like actually multiple hidden layers? For our specific case, vocab size is roughly 65 and embedding is 32. We are compressing the representation slightly. Let's implement that forward pass now. Oh, hello Gojo. It's no problem. It's Friday. Are you excited for the weekend? Of course. Yeah, me too. I've had a headache all day, but that can't dampen my spirits when it's Friday. I ate such a enormous dinner a few hours ago, so I'm still stuffed. I'm like sad, you know, sleepy yet full of energy at the same time. I don't know. Like I'm in a food coma, but I'm still like hyperactive mentally at the moment. It's a very strange sensation. We're doing some more programming today. Okay, what? I seriously need to fix. Wait, okay, now this is getting ridiculous. We got 4 bots at the same time. And since I haven't fixed the duplication glitch, it replicates. Oh my god. I need to fix that for tomorrow. Tomorrow is the path of pain, I think. I might try a Pantheon run at least once if you think it's worth it, but otherwise, yeah, it's path of pain. Alright. So, recap of the goal. Get embedding... Oh, we already did this, so... I mean... I'm guessing it's waiting for me to simply copy and paste this to show that it's done. Ooh. Let's see. I realized that like the last stream, the last programming stream, I had forgotten to trigger guided learning down here. So that was the reason the answers weren't like optimal. Apparently I have to do that on each time like you open a chat window, else it will like vanish for some reason. I don't know. It would have been neat if you could like, I don't know, mark a specific conversation as a learning conversation or something like that, and then have that like permanently on, but well, I guess you learn. How are your Python projects coming along? I think you were planning on doing like a Python game. That wasn't the Hangman. This looks spot on. You have successfully rewired the model. Let's trace the path of the data one last time to make sure we are visualizing the 3D block correctly. So input IDX, the shape of BT, integers, batch and time, or what can you call it instead of time? Sequence? No, block size. But we don't want to use block size because that would be pretty confusing with batch size, probably. And see channels. I need to grow comfortable with calling it time, but time seems so abstract for some reason. Holy shit, there are a lot of bots. Why did like so many bots suddenly invade my channel? Weird. Well, okay. So shape BT, batch time, integers, token embedding table converts integers to feature vectors. New shape BT and embed, also known as 32832. In this case, wait, why is it 32? Shouldn't it be 65? Shouldn't it be 65? 8, 32. Am I going crazy? I see exactly where you're coming from. It's very easy to mix up batch size and the vocabulary size. Especially when we are dealing with so many numbers. Let's distinguish between statics table we look things up in and the active data flowing through the model. The static menu embedding table. You are right that the token embedding table itself has a vocab size, rows. We're right that the token embedding table itself has vocab size, number of rows. Yeah. This sits in memory waiting to be used. It contains the vector the vector for A, the vector for B, etc. The active orders the input batch. However, when we run forward, we aren't passing in the whole dictionary. We are passing in a specific batch of data to train on. Oh yeah, that's true, that's true. And that might be 32, who knows. So, and those are 8 in time or in length then, in characters or tokens or whatever. Opened the stream and immediately got called to help. Oh, okay. I was wondering if the bots got to you or something. I don't know if you saw, but immediately after you wrote, there was like, I think we have, wait, 1, 2, 3, 4, 5, 6. There's been 6 bots from Kik. And since I haven't fixed the issue where they, like, their first message gets duplicated, it looks like we have 12 bots spamming. I don't know why, but for some reason this stream got added to the bot network today. Yeah. True. We're being raided by bots. And like there's usually no point in even banning them because they come into the stream and they write once and then they leave. That's all they do. So there's like no point in timing out or blocking or anything. Did I say something? Oh yeah, I did ask you if you'd gotten anywhere with your Python project. Like if you'd started your new Python game, I think you mentioned wanting to do a Python like text adventure or something, right? Like after the Hangman project. This means we have 32 parallel sequences, each 8 characters long. The lookup operation for every single integer in our input batch, 32, 8, will look up its corresponding vector length, 32. Oh, of course, because we have a batch of 32 in this scenario. It's just so confusing that they chose the same number here, but whatever. I'm still thinking about it, might start it soon. I mean, like I don't know if the programming like logic itself would be too difficult. I'm just guessing like writing the story is gonna take some time. Ooh. Wait, now we got a Twitch bot and a kick bot. All these bots, man. Why today? Maybe both streaming websites had an influx of bots or something. Yeah. Yeah, There probably are a lot of like text adventures hooked up to like LLMs. I've never played one, but I can imagine like there being stuff like that you can play online if you want to. International Bot Day, trademarked. I love this symbol. Yeah, trademarked. I've never really like gotten like it explained to me what the difference between a copyright and a trademark is. Is like a trademark something that can own a copyright? Or is it only the name that's copyrighted? Like it's trademarked? Only they can use the name, for example? Like one entity has the trademark of the name? I don't know, yeah. It's one of those things that you like take for granted. You never like really care enough to look it up, even though the distinction is probably like actually really important if you like work with stuff like that. But since I don't, I've never like really thought about it. For every single integer in our input batch, 32 and 8, we'll look up its corresponding vector, length 32. So the shape transformation looks like this. Input, 32 batches with 8 time or characters or whatever you want to call those. And since we're passing it through the embedding table, what gets added is the 32 of depth, or whatever you want to call that one. The channels, maybe. I don't know. So that's the vector for each one. 32 batches, we still have 32 sequences. 8T, each sequence still has 8 is still 8 tokens long, and the T does not stand for token, it stands for time, which is confusing as fuck. And then we have 32C, each token is now represented by a 32-dimensional vector instead of a single integer. So we can point that to more interesting things, like maybe another token entirely, whatever. Does that distinction make sense? The vocab size 65 is just the limit of what numbers can appear in the data, but the batch size 32 is how much data we are holding right now. Quick check: if we decided to double our trading speed and set batch size to 64, what would the new shape of TOC embed be? I mean, that would be, because that's, wait, TOC embed is simply the IDX passed through the embedding table, and the embedding table outputs. So that has to be TOC embed equals, maybe we should simply do 65, 8, wait, 65. Or wait. $64, it says there. 64. 64, 8, and 32. Right? Hopefully. Hopefully. Please don't tell me I'm wrong. Because I'm gonna be so confused. Exactly. Woo! Thank God. Thank God. You only changed the batch size B, so only the first dimension of the tensor changed. The sequence length T equals 8 and embedding dimension C equals 32. stayed exactly the same. Now, let's see this new architecture actually works. Did you run the updated master file py? We didn't do anything of this, did we? Let's trace the path of data. Oh, actually run the code, okay. So we're only supposed to run it. Oh yeah, because we defaulted that to 32, we don't need to set that anywhere. Now, do we do .then /scripts /activate.ps1, and then we do Python. Gonna move my keyboard a bit. Python master file, not fail, file dot py. Fun fact: if you press Alt F4 on your computer, you get a $500 reward. Try it. No. I wonder how many actually fall for that, like, each day. Like, they have, like, their friend or whatever, like, tell them, like the friend is having an issue and they say, like, press Alt F4 and they do it. It has to be, like, a pretty large amount of people that do that each day. I wish, like, since Windows is already, like, spying on us and collecting all our data, they should, like, collect metrics on stuff like that and then give us some, like, nice fun scoring, like, every month. Like, this many users got trolled into doing Alt F4 this month. A new record. Ooh, an automatic emote. I didn't even know that was possible. I updated the emoji system though, so now if you, like, use on your phone or whatever, like, multiple emojis, hopefully it will not add those strange characters, because they got converted into a token now, and then the token later gets converted back into an emoji. So that should be fixed, hopefully. Yeah, seems like it. Big brain. Nice. Mind blown. Now I only need to fix the kick. First chatter double thingy. Well, I'll do that tomorrow. Okay, wait, so I never actually looked at our answer here. But we're getting step 0, we have a loss of almost 4. A vocab size of 22. Right, because this is our text here that we're trending on. And we're decreasing the loss pretty steadily down to well, I'd say, like, it seems like after, like, the 1000 steps, it's entirely superfluous to even train it. Very nice result. Thank you, big brain neural network. I like this answer. Is that supposed to be an emoji, or did you write that yourself? I'm gonna guess you wrote that yourself. Wait, is that a shy face? Are you shy? do wonder if I can... Probably close that one. I have a built-in feature with these faces. I do not have the character needed on my keyboard to make them myself. Ah, right. Wait, is that a guy praying? What is that guy doing? It's like... what? What? Oh, okay, that guy's suffering. He's mad. He's raging. Ooh, that's some business emoji. Not some businessman. He's all cool and collecting the money. Maybe a loan shark. I don't know why, but those eyes make me think of like glasses. Like, you know, those like party glasses, or I don't know what to call them, like plastic, really ugly, like they're supposed to be phony. And that's a classic. Table flip. Absolute classic. I've never flipped a table. Like, it has never occurred to me to like just take a table and flip it in rage. I don't know. I'd rather like, I don't know, hit the table than like throw it away. I don't know why. Lemmy? Who is Lemmy? Is that Lemmy? Does he look like someone named Lemmy, or is he actually called Lemmy? Like, that face is called Lemmy in meme culture, whatever. It's called Lemmy. I had no idea. I don't think I've heard like the name of any of those like text characters. I didn't even think they had names. I mean, the table flip is probably called simply table flip or something, but the rest I had no idea. Yeah, that's me basically. Like, I don't know. I don't know. That kind of looks like a teddy bear though. Teddy bear. Teddy bear. Teddy bear. Teddy bear. Success! The code runs without errors. Rocket launch. Let's go to Mars. Look at that loss curve, dropping from 3.36 down to 0.9, and that represents a significant improvement in the model's confidence. It has learned the statistical relationship between our characters quite well, at least as well as a diagram model can. However, we have to talk about the results. It is still stuttering. Yeah. And I thought you said it wouldn't do that when we upgraded the model. I didn't understand why that would be, but it seems something is wrong. Detective work. We have upgraded the architecture to use embeddings, a hidden dimension, giving each character a rich vector of 32 features, but the behavior hasn't fundamentally changed. Let's look closely at the data flow in your forward method again. Let's colonize Mars. Yeah. I do wonder if that will happen in our lifetime. Like, I know for a certainty that it could happen in our lifetime. Like, if a lot of... Like if a lot of the world simply came together and like said, yeah, let's do that, then we'd be able to like colonize Mars in probably, I don't know, 20 years or something. Like have a colony stable and like people living there in 20 years, surely. At least that's how confident I am. But I don't know. All these billionaires have their own goals and stuff like that. So, I don't know. It would be pretty cool though. Ooh, we have a time traveler in chat. I had no idea you were time traveler, Gojo. 2056. To be honest, like, it kind of looks like we're heading towards like Cyberpunk 2077. Like when I saw like that game for the first time and like saw the timestamp for when it occurs, I was like, yeah, they know. They know. Have you played Cyberpunk? Token embedding self, token embedding table ID X, look up features for current character. Logit self LM head, token embedding predict next character from features. In this setup, does the model use any information from the previous characters to predict the next one, or is the prediction for a specific token based solely on itself? People thought we would have flying cars in 2025, instead we have brain rot. True. No. If you have like a console or a good enough PC, then I can recommend that game. It's very good. It's pretty... It's really like awesome, but pretty depressing as well, because you can see how much like humanity's worst traits get amplified in a very realistic way. Even though it's like pretty sci-fi with all like the implants and like they have like the what's it called? The data crash with the AIs taking over the old internet and stuff like that. Even though it's pretty sci-fi, like you can see so much of like the darker parts of our world in their creation. I really like the Annapurna interactive games. Annapurna. Never heard of that. Annapurna Interactive. An American video game publisher and developer. The company was founded in 2016 as a division of Annapurna Pictures. Oh, they made Stray. I've actually thought about playing Stray because it seemed very interesting. Even though it's mostly like a story game, there's like not much gameplay as far as I'm understanding it. Why can't I see? Oh, show more, okay. Yeah, Stray, okay. You finished it? Was it good? Did you like it? Ooh, with Outer Wilds, I think it's a pretty popular game as well. Never played it though. Very good. I think they have like a 98% or something overwhelmingly positive on Steam for Stray, I think. Or maybe 96%, I don't know. It's very positive rated at least. And I do like cats, so it might be a game I'm willing to try. Other than that, I can't say I'm like familiar with any of these games. I might have seen like snippets of some of them, but I played Outer Wilds, Stray, and now I will probably buy what remains of Edith Finch. What remains? Where did I see that? Here. What is that? A collection of strange tales about a family in Washington State. So it's like a story game. Is it like a... released 2017, so it's not a new game, but still. Alright. They have lots of just story games. I've been like pretty tempted about playing like Dispatch. I've seen like just a little bit of it, but it seems like people really like that game, and it that's also a story game. But I'm not sure. I'm not sure. Maybe. Why is it asking me to do detective work? It should know perfectly well itself what the issue is, right? I've heard about it too. Yeah, it's like a superhero game. I think it's like... I'd say the art style is somewhere in the middle of, like in between... Oh my god, what's it called? The oh my god, Invincible, like the Invincible TV series, and like Spider-Man Into the Spider-Verse, like somewhere in between those art styles. It looked like to me. It looks really good. Like the art direction seemed very nice, and the cutscenes as well. But I don't actually know like what you actually do in the game. Like I'm guessing it's simply to do like multiple choices. You have to like steer the story and stuff like that, but maybe there's some puzzles as well. I don't know. So now I need to debug this Bigram language model. Alright, let's start with the init class. So we're initializing am I saying that correctly? Initializing, yeah. We're initializing the class with the self-referencing itself here with the vocab. We pass along the vocab size, and we're defaulting the number of embedding dimensions to 32 here, but we can override that when we create the model if we want to. And then we're calling the initialization of its superior, or whatever. Like the neural network module. And then we're creating something called an embedding table, or a hidden layer. And that's we're set to or like neural network.embedding. And we're creating it in the dimension of vocab size and the number of embedding dimensions. So the rows are the vocab size, whatever we're using here. I think it said 32 vocab size from this text here. So in this case, it's going to be 32 rows and... No, 22 rows and 32 columns. And then we're also creating a LM head. Oh my god, why do I not remember what the LM stands for? Linear matrix, maybe, perhaps, I don't know. And that's a neural network.linear. And it has the rows of an embed, so 32 rows, and 22 columns in this case in vocab size. And then we have the forward function here that we call when we pass along the IDX or the when we pass along the data that we want to either get an answer for or want to train on, whichever. So this is a tensor, and it can be whatever size we want it to be, essentially. And in this case, it's a 1 by 1, so 1 row, 1 column, a straight up 0, that's all we have. And we pass along that. And then we pass along that through the hidden embedding layer. And what we get is the token for the embedding. So what this does is it's gonna add the embedding table dimensions to the IDX. So this is literally gonna be, well, this is gonna be a 0. How would this look like if you had to draw it out? It would be rows of 0. Then with, wait, no. It would be rows, 22 rows. And the first column would be, the first column would be zeros. And then we'd have but that's just the first round. Oh my god, that's so confusing. Are you with me, Gojo? Or have you entirely clocked out? This is so confusing. Then what do we do here? Let's say if we were to with max number of tokens, that's the generate function here. Forwarded training. In range 10,000. What if we do this in 1? Oh, and here we have the batch size as well as 32. Kind of want to print token embedding. Let's do as a formatted string took emb like that, as well as the logits afterwards. Logits, not in caps, and the logits. Can we do that? Will that allow us to get... Ooh, we printed a lot of them. Wait, did we have range 1? Doesn't it do that one time? Why did it do that so many times? Is it because we're doing max new tokens? Yeah, that's the reason. So if we set that to 1 as well, we'll only get What is this? That's a new one. Okay. So here we have the TOC embedding tensor. And logit tensor. It's definitely shorter, right? It's a bit confusing to see how this actually looks. But can we do shape, maybe? Logit.shape. That might make it less confusing to look at. Yeah, okay. So, the token embedding is 32 for the batch size and 8 for the time, and then 32 for the depth or the channels. And then the logit becomes 32, 8, 22, because we have the vocabulary, right? We're converting that down to a vocabulary size. And that's when we're training it. When we're simply passing stuff through the forward here, then when we're generating here, so we're not getting any loss back. Is that what we're doing down here, maybe? 2000 years later? Did you go somewhere and come back and see me struggling here? Because, I mean, Gemini said to do detective work ourselves. Yeah. So I'm trying my damn best here to find out whatever the issue is, but I don't know, man. This is damn confusing. I don't suppose you understand this any better than I do. I'm just gonna say, I don't know. In this setup, does the model use any information from the previous character to predict the next one? Or is the prediction for a specific token based solely on itself? I don't know. I don't know. Try to figure that out, but seems my detective work needs some improvement. So let's see. It's at 10,000 here and max new tokens 100. Did we change anything else? No, I don't think so. Alright, Let's read the answer. No worries at all. It's a bit of a trick question because we are feeding it a sequence of 8 characters, so it feels it should know the context. But let's look at the math operations again. I'm betting we look up the vector for the character at position t. This lookup doesn't care what is at position t minus 1. Linear ahead, we take that specific vector and calculate scores. This operation also doesn't look at the neighbors. Think of it like a row of people in voting booths. They are standing right next to each other in the sequence, but there are walls between them. They can't see or talk to each other. So if the input is hell... okay. Oh, this is kind of hell. The model processes the final L completely alone. Okay, so it's ignoring the hell. Does the calculation for that final L know that age came 3 steps before it, or is it flying blind regarding of the past? It's flying blind! This is actually something I was wondering about beforehand, but I never voiced it, thinking like it's gonna probably fix this. Like it's probably counting on me not fixing it myself. That's a good solution. Let all the voting people consult each other. Exactly, so that's what Gemini is telling us now. It's telling us that we're not supposed to do voting in booths. We're supposed to do voting where everyone can see what we're voting on. That's totally what it endorses. Imagine like someone not knowing what they're gonna vote on, so they like look at their neighbor and just copy whatever they're doing. Like if it was as if it was like a test for a school or something like that. Copying the homework. I wouldn't be surprised if that happened. Someone is going to vote because they wanted to go and vote, and then they stand there like, what the hell? And then they look at their neighbor and like, well, sure, let's do the same thing. It's like blind. Ooh. Integrating positional context, adding positional signals, defining the contextual framework, implementing positional awareness. Alright. That's exactly right. Even though we are feeding it in a sequence of 8 characters, the model is processing them individually. It has amnesia. It has small brain. The calculations for the 8th character has no access to the 7th, 6th or 1st character. It's just guessing based on the current character alone. To fix this and to build a transformer, we need to solve 2 problems. The where am I problem. The model doesn't distinguish between A at the start of the sentence and A at the end. They get the exact same vector. And 2, what happened before problem. The tokens aren't talking to each other yet. They're not sentient. Let's tackle the first one. It's a quick win. I choose, looks nervously at the neighbor. Answer B. Damn it! And I was about to write answer C. Well, can't be right all times. If token embedding table allows the model to look up what the character is, what kind of lookup table do you think we might need to help the model understand where the character is in the sequence? 0, 1, 2, 7. What is this math, man? What is this math? Voters! Remember, always check who your neighbors are voting for so you can consult them or immediately command them to change their vote. I love democracy. Man, democracy, I don't know. Sometimes you just look at the stuff people vote for and you just face palm. and you wonder what's the point with democracy? And then you remember the alternatives and you're like, oh my god, do we really need this? Oh, damn it. You can't win sometimes. What is this question? If token embedding table allows the model to look up what the character is, what kind of lookup table do you think we might need to help the model understand where the character is in the sequence? Do we need to add another dimension for that or something? I don't quite understand your question. Even if democracy is sometimes bad, remember communism. There's a lot of stupid ideas out there. Like a lot of them. The question is, if the people vote for communism, do you give it to them? Or do you not? Because not giving them communism would be anti-democratic. Like that would go against every principle of a democracy. Like that would be like authoritarian. So you can't like hold to democracy like 100%. Like you just can't do that. And then the question comes in, well, where do you draw the lines? What should we allow the people to vote on, and what should we ourselves, the party, whatever, would like the governing body decide for ourselves? It's so messy. I don't know. When I was younger, I was all in on democracy. But the more you like understand of it, like the messier it becomes. Can we leave the moral dilemmas, please? I'm not good at these. Yeah, I have no answers. I'm just saying I have no answers to these questions either. I'm just voicing the questions. I don't think anyone has like definitive answers either. Like, people's answers depend on their own philosophy, I guess. And I'm not entirely sure where I stand on that, to be honest. I'm not sure. I don't care enough about politics. Alright. Let's see what it says here. No worries. Let's clarify the problem with a specific example. Imagine our input sequence is just two identical letters AA. The first letter A is at position 0. The second A is at position 1. In the time sequence. Yeah, that makes sense. Like in the rows or whatever. Right now your model looks up A in the token embedding table and gets the exact same vector for both. To the model, they are identical clones. It has no idea which one came first. To fix this, we need to give the model a seat number for each character. The solution, a second table. We will create a second lookup table called position embedding table. All table tokens. You give it the character, for example, A, and it gives you a vector. New table positions, it gives you position index, for example, 1, 2, 1, 0, 1, 2, and it gives you a vector representing firstness, secondness, and secondness. These can't be real words, can they? I've never heard someone saying firstness and secondness. That doesn't sound like English. What are those emojis? Was that supposed to be like a broken web page and a... What even is that? Like a radioactive symbol? No, what is that? Like a hazard symbol, I don't know. Then we just add these two vectors together. So final vector becomes the token vector plus the positional vector. Oh. So who am I plus where am I? Now we're asking the real questions. What's the meaning of life? Maybe the next vector we're adding. Yes, biohazard, I think. What is gombok? Gombok. Is a homogeneous, convex, three-dimensional object that has only one stable and one unstable point of equilibrium. I'm not getting that. That doesn't render for me. Seems I can't get every emoji rendered. The Gambuk. Hungarian. Monostatic. Meaning they have just one stable and one unstable point of equilibrium. Resting on a flat surface. Russian mathematician Vladimir Arnold. What the hell is this? Roly-poly toy. Oh. Mountain chicken. Mountain chicken. What? What? The Leptodactylus phalanx, commonly known as the mountain chicken or giant ditch frog, is a critically endangered species of frog that is native to the Caribbean islands of the Dominica and Montserrat. The population declined at least 80% from 1995 to 2004 and further significant declines later. Yeah, that is one hell of a chicken. Oh, they eat the frogs. That's why. I've never eaten frogs, but these look kind of tasty, not gonna lie. Like normally I'm like, frog, why? But that looked kind of tasty. No, not AI mode. I have nothing against them having a tab for it, but why have it to the left of all? Please put it somewhere here where it won't to get in the way. And Hot Wheels Sisyphus. What? What is that? Sisyphus. I don't know why that word sounds suspicious. Ah, it's a guy pushing the rock up a hill. What do you mean Hot Wheels? Hot Wheels. What is that? Is that a spider or something? Spoderman. People have all kinds of weird names for stuff. All the weird names, yeah. Though, what's his name? Carl von Linné. Is that Linnaeus? This guy is the OG when it comes to naming shit. He knows how to name shit. He named so many damn things, like trees and I think animals as well. Oh my god, his page is enormous. He created like a naming conventions, right? Pretty neat. But he named stuff in Latin, so I guess maybe his names are very strange. But since it's in Latin, I don't know what it actually means, so it simply sounds cool when you say it. Who formalized bionomical nomenclature? It's a formal system of naming species of living things by giving each a name composed of two parts, both of which use Latin grammatical forms. Okay. There's even a Sonic the Hedgehog protein. Who would name a protein after Sonic? Is it called like the fast protein chain or something? The fast Sonic chain. Hedgehogs are really cute though. I haven't seen a hedgehog in so long. I don't know what happened to hedgehogs. They simply disappeared. It's so sad because they are so cute. So adorable. Like, have you seen like those like videos on the internet, like of people having like pet hedgehogs? Like they, ooh, you just don't wanna like scratch their little fluffy tummies. They're so cute. No. I mean, look at this guy. He's so cute. Look at him. I mean, look at him. He's so cute. It looks so fluffy on the inside and they're spiky on the outside. I mean, I don't know, I think they're adorable. But it's been such a long time since I saw like a wild one. Which is sad. I think like cars have taken their toll on their population. Enough about hedgehogs. If our token embedding table need a vocab size rows, for one for every unique character, how many rows do we need for the positional embedding table? How many rows? Hint. What is the maximum length of a sequence we decided on earlier? We call it block size. I mean, we have an 8 in block size, I think. So So I guess that makes sense if we have 8 positions. And then the columns in like the columns. So if, or wait, if the rows are the positions, like 8 of them, and then the columns, why is that so confusing for me to grasp? You'd think you'd need a position for like the vocab size. On that dimension, because we need to be able to assert that that specific token in the vocabulary is on that position. I think. So position embedding table calls. What is that? So block size and vocab size is my guess. It's my guess though. Please let it be right. Please, please. I pray to the Google gods. Please. You're half right. Damn it. You nailed rows, block size. We definitely need a specific row for every possible position. 7, 1, 2, up to... Wait, 0, 1, 2, up to 7. However, let's look at the columns, the vector width again. Remember, our goal is to add these two vectors together. Okay. So total vector is the token vector plus positional vector. In math and PyTorch, you can only add two vectors if they have the exact same length. Our token vector from token embedding table has a length of number of embedding dimensions, or 32. If we try to add a positional vector of length vocab size 65, the shapes wouldn't match. Wait, because token embedding is 32, 832. Because it's batch of 32 and then 832. Oh, so we're ignoring the batches now. So we're ignoring the batch of 32. Just adding 832 to that. Okay, embed. I don't see how they can be the same size. That's the issue here. Hit the nail on the head. That is exactly what happened. So we want to add the same position information to every single sequence in the batch. Sequence 1 needs to know that A is at index 0. Sequence 32 needs to know that Z is at index 0. Huh? My brain. A poor brain. In PyTorch you can try to add a tensor of shape 832 to a tensor of shape 32,832. It automatically broadcasts the smaller one. It effectively copies that 832 block 32 times to match the batch size. Oh. Okay, so that's how it works. So when you add it to that, then it will do that 32 times effectively. Well, that's confusing as all hell, but I see. Think of it like a cookie cutter the dough. Your batch of data 32 layers thick. The cutter, your position embeddings one layer. You press the cutter down and it applies the exact same shape to every single layer of the dough at once. A weird analogy, but I think I get what it's trying to say here. Hands-on, create the position IDs. To get that 832 tensor, we first need to look up the vectors for positions 0, 1, 2 to 7. We need to generate a tensor containing the numbers 0, 1, t minus 1. Alright, because t is the, not the batch, but the, what do we call that? Not the batch, but the, batch. No, not batch. Something else on the B. Block size. Right. All these words. All these numbers. Okay. So basically block size minus 1. Okay, do you know which PyTorch function generates a sequence of numbers 0 to n? Hint, it's very similar to PyTorch built-in range. Python's built-in range. I'm just gonna go out on a limb and guess it's something like torch.range. Is it torch.range? You're very close. It's actually torch.arrange. I'd never get that on my own, so good that I actually provided a answer, even though it was faulty. So torch.range is an older deprecated function that includes the endpoint, like 0, 1, 2, 3, 4. Torch.arrange works exactly like Python's range. That's confusing. It stops before the limit, like 0, 1, 2, 3, which is exactly what we need for zero-based indexing. Dynamic length. There is one small catch. Inside forward, we can't just assume the length is always block size 8. When we start generating text, we might pass it just one character, then 2 characters, then 3. True. if we only have like a 0 to go on, for example, then that's true. So we need to create our position number 0, 1, 2 based on actual length of the IDX tensor coming in. Looking at your forward method, you already have this line, BTC logits shape. Wait, logits doesn't exist yet at the start of forward. No, we're creating logits here. Let's look at IDX. It has shape BT or batch and time. And here is the... How do I keep forgetting whatever that's called? Block size. But we call it time here. How can you extract the current sequence length t from the IDX tensor and then use it to create your IDX using torch arrange? Try writing those 2 lines of code. Okay, that's a hint at least. So we have 2 lines of code we need to write. So... I guess we can do that before we even pass that through any embeddings or anything. So wait, do we want to do pos IDX equals torch dot arrange from 0 and then the end number to be IDX? Now we need to access the length of whatever that is. Can we do IDX 0? Wait, we want to do the T, so 1. This is probably wrong, but I'm gonna do it like so. Copy that. Let's see what it says about this function. We also probably need to do -1 now that I'm thinking about it. That was probably wrong anyways. I was thinking if this meant the t dimension, but I don't know. Our len IDX1 has a small trap. If our batch size b is only 1, which happens when we start generating text, IDX1 will try to access the second row. Oh, I didn't want to access the row, I wanted to access the t. It is safer to get the dimensions directly from the tensor's shape. I see. Wait, can we do idx.shape.y? No, that sounds weird. We have the position indices post IDX, but we have 2 missing links to make the transformer architecture work. The table, we haven't actually created a positional embedding table in init yet. Oh, right, true. Is that a burrito? What is that? Did you go and get some food or something? Oh, it's been so long since I had a burrito. I think the closest thing I've had is like a chicken wrap I made myself like 2 months ago. No, just another emoticon. But what is it? It has to be something, right? I can't copy it unfortunately, so I don't know what it is. At least I don't think I can copy it. Can I do burrito if I paste here? No, it doesn't work. Okay. Sad. Sad. Burrito. Okay, so your task: update the diagram language model class, both diagram model class, both init and forward. Init create self position embedding table. Yes, we can do that here. Self position embedding table, and then dot embedding of block size and an embed. Because the block size is the maximum context length, so the amount of rows, and then the embed is the embedding dimension. Does that then become the position? Oh my god, I'm so confused. In forward, get t safely. Okay, so that's the safe way to do it. So bt equals idx.shape. That's one way to extract it, and then we can do pos idx equals is it len or t? Maybe. What does this complain about? Is it that we're not using it? Oh, never used, okay. Then look up the position embeddings, pos embed. Ooh. Okay, so pos embed equals self.position embedding table pos idx. And then we need to add them together. Yeah, that's kind of how I'm feeling at the moment. Like, what is going on here? So here we do x equals took embed plus pos embed. And then we're gonna pass x here through the head instead to get the logits. Small brain moment. I sent you a small brain. Was it so small that I can't see it? That's really tiny. Ooh. Is that from a game or something? Intellect level 1 and dumbass. Oh my god. Intelligence scoring in games is somehow, I don't know what to call that. It was Yakuza. I was about to say, is that like a Yakuza or something? Because it, like the art style, I never played it, but I saw some of the what was it called? Yakuza, like the pirate version. Oh my god. Damn it, I forgot what it was called. Same. Okay. It looked really fun though. Like it looked like a fun game. I would be kind of down to try out the Yakuza games because I've heard like they're really good, but I've never played any games like that where you just go around and beat people up. Like never, I don't think. Okay, so let's see what it says about this. Please be happy. Please. I beg you. I beg you, Google gods. Be happy with this poor supplicant's meager offering, please. You nailed in its setup. Your position embedding table is definitely correct. Is defined correctly with block size and an embed. However, we have a small logical bug in forward that will cause a crash. Damn it! Since B and T X shape unpacks the dimensions. Oh, right. Right. It's just an integer. For example, 8. Python will error out if you try to ask for the length of a number. I guess that makes perfect sense. So we can do that instead. We need pos IDX to be a 10 so to contain the sequence. Oh, I see. I forgot about that. So we do torch dot arrange 0 to t minus 1. That has to be it. Even as a trash can? What is that thumbs up? Just like, yeah, this is my trash can. Deal with it. You were on the right track with torch arrange, but remember the end parameter is... Oh, it is exclusive. Okay, then we don't need the minus 1, okay. So this has to be correct. Small brain. Yeah, small brain. I guess my thumbnail didn't speak the truth today. I felt all big brain going into this, but now I feel like so wrung out mentally. Maybe it's the food coma striking back. It's getting its revenge on me. Bingo! Torch arrange 0t gives you exactly 0, 1, 2 all the way up to t minus 1, which corresponds to the indices of the rows we want from the position table. Since toke embed is shape btc and our new pos embed will be tc, PyTorch will automatically broadcast copy that position information across all B batches. When we're doing the plus here, that is a funky operation where this gets copied when you do a addition. But if that's how it works, then I guess we simply have to trust the process. With me talking results in small brain. What? The Stegosaurus had a brain size of a walnut or some other nut, I don't remember exactly. I think I heard that. But I mean, like a big brain is very expensive. And I mean, like, a Stegosaurus didn't need a big brain to be dangerous, so they simply didn't have a big brain to be dangerous. No solar reaction. Okay. I think the T-Rex also had like a really small brain. I might be wrong though. Did the T-Rex have a small brain? Not necessarily small. Oh, so it was smaller than a primate's relative to its body size. Ah, so it was on the level of a monkey or baboon. But other studies argue for a more crocodile-like intelligence. I don't know, I wouldn't say crocodile is intelligent though, so... The T-Rex brain was a fraction of the size of a human brain in proportion to its body weight. But this doesn't mean it was small for a dinosaur, yeah, okay. Because most dinosaurs had even tinier brains, probably. T-Rex had super useful arms. I know, like, I know they had like really tiny arms, but were they like used for something? Did the T-Rex tiny arms have a use? Yes, the T-Rex tiny arms had several uses, although their exact purpose is still debated by scientists. Okay, so they don't know what the fuck they did with those tiny arms. Potential functions include helping them stand up after lying down, gripping prey, and holding mates during reproduction. The arms may have been strong enough to hold the prey to its mouth or perform other small but crucial tasks. I mean, it would simply bend over and bite. It wouldn't need those tiny arms for that. Assist him getting up. Doubtful. Grasping prey, doubtful. It simply would bite and then that would be it. Like, reproductive behavior. That's the only one I could see, like, for balance. Like, that's it. An evolutionary trade-off. This makes the most sense to why they're so small, because they don't need them, because the rest is so big, I don't know. Really small, yeah. Absolutely tiny. But I don't know. I think like the tiny arms, it makes them look like a bit derpy, sure. But in some aspects it almost makes them look more like ferocious and dangerous. Because it looks so alien in a way. At least that's how it is to me when I see a T-Rex. Like if you had removed the arms, then they would simply look like some strange bipedal creature. Like a bipedal lizard. I guess it is a bipedal lizard, but you catch my drift. Like it would look like more uniform, but the tiny arms makes it look more dangerous in a way. Did you know the reptilians live among us? Among us? 100% legit. Yeah, there's a lizard people in the government. Yeah, I've heard about those. There's a bunch of lizards in Florida. A lot of lizards. We don't have many lizards in Sweden. Mostly like... The only like really lizard I see is like the copper snake. But that looks more like a snake even though it's a lizard. Queen Elizabeth II was one of them. She was one of them. How do you know she's still not among them? She simply retired from the public scene to go and sleep in the center of the earth with the other lizards. Died. How do you know? Really? How do you know? Did you see her die? I didn't see her die. I simply saw other lizard people telling me she was dead. Have you ever thought about that? I do wonder, like, people who actually believe like there are lizard people, like controlling the government. Like, I mean, there are more believable conspiracies to shout from the rooftops. Why lizard people? It's just such a strange thing, like lizards. Why lizards? I mean, I can get snakes because of like the symbolism and all of that, but lizard? It's very strange. A long time ago they had such bad healthcare that they installed bells close to the caskets. So if someone was mistakenly buried, they could swing a rope and make a noise to get them out. I'm just like, if that's true, I'm just wondering like the logistics of that. Like, how often would they have to be incorrect for that to even be a thing? Imagine waking up in a coffin. You'd feel like a vampire. I think I saw like a program growing up, like a guy that like voluntarily like got sedated and then buried in a coffin, and then he had like, then he woke up there in the dark and had to like get out. Man, just me remembering that like almost gives me claustrophobia. Mr. Beast? What? Did Mr. Beast do something like that? I'm talking about, I don't know, 15 years ago or something. Like a really old program, even older, that I saw on like on television. It's, like, I mean, something that I saw when I was really young. Mr. Beast. Mr. Beast coffin. Oh. I never seen that video. 7 days. That must have been... I could probably panic in the beginning, and then it would simply been boring and nasty. I mean, because you have to like defecate and all that. Not nice. Good night, Gojo. Good night. I hope I'll see you tomorrow with some more Hollow Knight. We'll probably do the Path of Pain, but maybe some of the... What's it called? The Pantheon as well. Try it out at least, in the beginning. We'll see. But that's the plan at least. Remember to let the voices in your head be heard before you go to bed. Scream. Yeah. Yeah. I'm gonna pass those voices on to you. So if you hear something in your dreams tonight, you know it's from my own head. Sweet dreams. Wait, did I... Wait. Go ahead and paste the entire updated forward method below so I can double check the logic. Oh, okay, so... It wants everything here. There we go. That should be good enough. That looks solid. You have correctly set up the forward pass to combine your token embeddings identity with your position embeddings location. You're now adding BTC plus TC via broadcasting, which creates a context-aware representation for every character. Hopefully. This stress test, now comes the moment of truth. Go ahead and run your master file py script. I suspect you might run into a specific error pretty quickly, like when it tries to generate. When you see it, paste the error message here and we can debug it together. You have 10,100, okay. And we've saved the file, so let's go and run it. So we're training it and the loss is decreasing. It's entirely superfluous to do more than 1,000, but okay. And here we have errors. Let's let's copy all of this so it knows. Alright, so what is it? It's actually doing line 2547. Index out of range in self. That is a classic growing pains error. You have encountered an index error, index out of range. Let's play detective. The traceback points specifically to this line in your forward method. Post embedding, self position embedding, stable position IDX. Oh, does it know that? Because it seems like we're getting this here, logit loss, and that's... Wait, 65. 62 here. So in the generate we're passing IDX, which is a 0 on the first run. Is it that we're adding too many symbols? Like if we were to only generate, let's say, I don't know, let's try simply generate 7 new tokens. I'm just shooting in the dark here. But would that work? So that works, but for some reason we're getting A. I'm really curious to see how Gemini is gonna handle that. Because it seems like it says we should get something else pretty much every time, but we only get this result anyways. Which is weird. Okay. Pos embedding cell position embedding table, proceed IDX. And we know the error happens during the generation phase, not the training phase. To solve this, we need to compare two numbers. The limit. How many row positions did we allocate to in the position embedding table when we created it in init? Rows are set to the block size. The demand, as the generate loop runs and it keeps appending new token IDs, what happens to the length t of the sequence? Right, this is the t. So this one will go over, yeah, and this one will increase above 8. Wait, what eventually happens to t that causes it to exceed the table's limit? Each generation adds another length to the t dimension of IDX, meaning that after 8 generations it's now 9 in size, I think. Exactly, you found a bug. Thank God. Your model has a fixed attention span or context window defined by block size, which is 8. The table only has seats for positions 0 through 7. The input during generation, the sequence grows to 9, 10, 11. When the sequence hits length 9, the model tries to look up position 8, but that row doesn't exist in the table. Crash. The fix. Sliding window. To fix this, we need to make sure that no matter how much text we generate, the model only ever sees the last 8 characters. Inside your generate method, we are currently passing the entire growing history into the model. Yes. How can you use Python list tensor slicing to modify that line so self 0 only receives the last block size tokens of IDX? Good question. Here. I'm guessing we're gonna do like the below here, so colon and colon to get everything there, and then we're gonna do colon here, and on this right side on the upper limit we're gonna do -1 for the last one, up to from minus either 8 or 9. This might give us 7. Maybe 9. Let's see if we give it this. What does it say? Oh. Oh, now we hard-coded that, which isn't great, I guess. We're gonna do from minus block size, I guess. You write on track attempt to slice IDX, limiting the input is exactly how we solve the context window crash. However, let's look closer at the specific slice and the dimensions. The end index in Python slicing like start end the end index is exclusive, it stops before that index. If you slice up to -1, will the model see the very last character in the sequence or will it be cut off? The dimensions IDX currently holds integer IDs with shape batch time, since it is only two-dimensional. Oh, will adding a third column at the end cause an error? I don't know, but it's probably not a good idea. That's for sure. Oh, didn't mean to edit that one. Batch size. Not batch size, block size. But if it's exclusive, we can't do 0, can we? Because -1... Wait, can we do -2? Will this work if it's exclusive? Well, let's give it all of this so it knows. Oh wait, you're getting warmer. You correctly use block size to define how far back to look. That is the hard part. However, the end of your slice -2 is cutting off the most important data. In Python, -2 means stop 2 steps before the end. So if your sequence was... Wait, so... Can you do minus... Can you do -0? Oh, this is a useless answer. Let's replace that with all of this. Weird that it didn't get like the context. Maybe I'm wrong and that's why. Close, you're thinking of the right concept. An offset of 0 from the end, but Python interprets -0 simply as integer 0. The index of the very first item. Oh wait, so you can leave it blank, is that what you're saying? So we start from there and go all the way. That has to be it. That would make sense. That is the one, okay. Leaving the second part of the slice empty tells Python to go all the way to the end. So it means keep all batches start at block size steps from the end and take everything until the final token. This effectively creates a sliding window. As IDX grows to length 9, 10, 100, the model only ever sees the most recent 8 tokens. You have fixed the crash. Go ahead and run master file again. Okay, let's try it. It's probably still on a loop, but... I should probably also stop training it so much, because there's no point to it. Alright. That is severely disappointing. There's something we're missing. I'm wondering if it's like the tokenization, like the byte pair tokenization or something like that. That's missing, but I don't know. It feels like it should be able to write this text without issues at this point. That's a huge milestone. The code runs without crashing, the loss is dropping, and you successfully implemented the sliding window mechanism. However, look at that output. It seems our model is a bit repetitive. You can say that again. We gave the model identity, token embeddings, and location position embeddings. It knows who it is and where it is. But let's look at the math one more time to understand why it's still not writing Shakespeare. In the forward pass we have x equals token embedding plus post embedding, logits equals self lm head x. When the model is trying to predict what comes after the fifth character at index 4, it looks at x4. Yeah. The million-dollar question, does the vector x4 currently contain any information about what happened at x3, x2 or x0? Or is it isolated? I mean, it should have the position data, shouldn't it? Because we're broadcasting this position embedding onto all of these time and channels for every batch. So why wouldn't logits equals self.lm head? My gut is saying no, but it looks like X has the positional data and the embedding data for each of the blocks. I don't even know how to spell that out. There's probably a much cleverer way to say that, but yeah. Trust your gut is absolutely right. While the entire variable x contains all the data, the specific window x4 is built strictly from token embedding table character at 4, position embedding table for... Oh, when the linear layer LM head processes x4, it processes it in complete isolation. It's like having 8 people in a room who know their names and their assigned seats, but they're all wearing noise cancelling headphones. They can't coordinate. Another weird metaphor. The missing link, communication. To get coherent text, the token at position 4 needs to know what happened at positions 0, 1, 2, and 3. We need to let the information flow from the past into the current position. We call this self-attention. But before we build this fancy version, let's try the simplest possible version. But before we build the fancy version, let's try the simplest possible version. If you have vectors for time steps 0, 1, 2, 3, 4, what is the simplest mathematical operation you can think of to combine them all into a single summary vector? I mean addition, right? Addition. If you simply add them all together. Spot on. You're absolutely right. The simplest way to summarize a bunch of vectors is just to add them all up. If I am token at position 4 and I want to know about the past, I can just take x summary, x0 plus x1 plus x2 plus x4 plus x3 plus x4. Now my vector contains a little bit of information from everyone. This approach is often called the bag of words model because it's just jumbling everything together without caring much about the order, beyond the position encoding we just added. A slight refinement averaging. There is just one small problem with pure addition: magnitude. if we sum 5 vectors, the numbers get big. If we sum 100 vectors, they get huge. Neural networks hate huge numbers because they destabilize the training. So instead of just a sum, we usually take the average, in parentheses, mean. So we divide the sum by the summed number, or the number to be summed. Okay. The implementation challenge. If we want to implement this average of the past for every single token in the sequence effectively, token 4 wants the average of 0, 1, 2, 3, 4. Token 2 wants the average of 0, 1, 2. Token 0 just wants itself. We could write a for loop to do this, but loops are slow in Python. We want to use matrix multiplication to all at once. Do it all at once. The math question: if you have a matrix of data, our tokens, what kind of matrix could you multiply it by to perform sums or averages? Hint: think about what happens when you multiply a matrix by a vector of ones. What happens when you multiply a matrix by a vector of ones? I mean, doesn't nothing happen? If you multiply by 1, it will simply be itself? Or am I completely out at sea here? I don't know. I'll be right back. Just gonna grab some more water. Hello. Alright. Alright. Okay. Then this leave the matrix exactly as it were. It's been so long since I did math like this, so I don't know. Don't flame me. I don't know. Damn, it's getting hot in my room. Why is it so damn hot? That's a very reasonable guess. You are thinking of the identity matrix, which has ones only on the diagonal and zeros everywhere else. What? That one indeed acts like a mirror and leaves the matrix unchanged, but a vector of ones or a matrix filled with ones behaves differently. It acts like a vacuum cleaner. It pulls everything together. The math check. Let's look at a tiny example. Imagine a single row of data, 10, 20, 30, and we multiply it, the dot product, by a column of ones, 1, 1, 1. Oh, a dot product. Okay. Instead of keeping the numbers same, it summed them up. That is weird. I don't know why it does that. I don't know if I need to know why it works like that, but it is weird that it works like that. Building the history matrix. Now apply this to our language model. We want to sum up the vectors of the past tokens. We use a matrix multiplication, AX, where A is our aggregation weights, T times T. X is our token embeddings, T times C. If we want a token at row 2 to be the sum of tokens 0, 1 and 2, but ignore the future tokens 3 and 4, what values should be in row 2 of matrix A? Hint, we need to activate indices 0, 1 and 2 and 0 out indices 3 and 4. If we want the tokens at row 2 to be the sum of tokens 0, 1 and 2, I'm honestly lost. What are we doing and why are we doing it? The why is often as important as the what. I've come to learn, especially when you talk to an LLM, because they can get pretty damn lost in the weeds along the way and start explaining stuff that's not entirely relevant. I completely understand. We just took a massive leap from concepts like memory to abstract linear algebra, and that transition is often the hardest part of this entire course. Let's take a breath and reset. The why, the goal. Right now our model stutters because it has amnesia. When it is at character 5, it has no clue what happened at character 1. Goal, we want the model to quote-unquote see the past. Mechanism, to see the past we will simply average the feature vectors of all previous tokens with the current one. This creates a summary vector. The what matrix. We could write a slow Python loop to calculate these averages, but in deep learning we want to process thousands of words instantly. The tool for that is matrix multiplication. We are building a special matrix, let's call it the weight matrix. Oh, so we're building a matrix like outside of the position embedding and the token embedding. Because this is a... Would the position embedding and token embedding count as matrices? Is that how it says about matrices? Matrices. Like, I'm not even entirely sure what would count as a matrix, or matrix, so... Yes, they absolutely do. Okay, you are thinking in the right direction. In math terms, a matrix is just a 2D grid of numbers, row times columns. The embedding tables, your token embedding table is a matrix of shape 65 times 32, or the vocab... Well, it could be vocabulary, but our vocabulary is not 65, it's 22 in this case, but whatever. Times 32, and this is... the number of embedding dimensions, or the channels, or whatever. The C in the BTC. The active data for a single sequence in your batch token embedding is a matrix of shape 8 times 32. Here we have the... Not the batch, oh my god. I keep forgetting what it's called. Block size. The block size times the N embedding. Oh, we can even see that here. Okay. Since we have a batch of 32 sequences, it's technically a stack of 32 matrices, often called a 3D tensor. But that's not present here. But it will be present when we're adding them together, I guess. The mixing operation. We have our data matrix X, the embeddings. Now we need a second matrix to act as a tool to modify X. We're trying to build that tool matrix, let's call it W for weights, to average our past context. Let's look at that specific row again for the third token, index 2. We want the average of tokens 0, 1 and 2. If we want the result to be result 1/3. Okay, that is a weird way to write it out, but I get the... And our row weights is W0, W1, W2. What specific number should we put in each of those 3 spots? What specific number? Yeah, I don't know. It might be that I'm still having a headache, or it might be that we're actually getting into some really complex stuff now. I don't know. Because I feel like up until today it was pretty easy to follow along, but now it's getting very, very difficult. If we call that matrix W, like W equals what then? Like what would that even be? Is it like X? No. I don't know. I feel like I won't get anywhere trying to figure it out myself at this point. Just give me the answer. No problem at all. Let's look at it with a simple equation matching game. We want to calculate the average of A, B, and C. The math of an average is 1/3 of A plus 1/3 of B plus 1/3 of C, or A plus B plus C divided by 3. Like the sum divided by 3. Now look at how the matrix multiplication works. It takes the weights W1, W2, W3 and does this. WA plus WB plus WC. If you compare those two lines, what number must W be to match the first equation? I mean, a third? A third? 1 out of 3? or the number of parts being summed. I don't know if you can call it parts, but my meaning should be plain enough. Okay, exactly. You solve the puzzle. To get the average of 3 items, the weight must be exactly 1/3, or roughly 0.33. The history matrix revealed. If we build this matrix for our third token sequence ABC, it looks like this. So row 0, 1, 2. Token A, token B, token C. Column 0 waits for A, column 1 waits for B, column 2 waits for C. So then we have, so 0, 0 is 1. But why does it look like this? Why? Oh, because here we only have one on the row 0 current token. So on the, if the current token is 0, then the weight for A is 1 because we're not adding it with anything else. But on the token that comes after, we're also adding in the B to the A. So we need to divide that by, okay. So basically all the number of parts being summed, basically that, but in a structured format like that, I don't know. Do you notice a specific shape formed by the non-zero numbers? We call this a lower triangular matrix. Okay. A lower triangular matrix. The critical 0 zone. Look at the top right corner, the 0 zeros. Top right corner, yeah. For example, look at row 0, token A. Why must the weight of col 1, token B be exactly 0? Hint, think about what token A knows about the future. Must it be 0 because the future hasn't been generated yet? Can't know what the future holds, so it can't sum and divide by it. I mean, that seems logical, right? How would it know the future? You hit the nail on the head. It is exactly because the future doesn't exist for the model at that moment, or at least we must pretend it doesn't. Because, well, yeah, if you train it, when you train it, I guess it does technically exist. But then when you generate text, then it doesn't exist. The no cheating rule. During training we do possess the full sequences. Okay, yeah. When the model is training on H index 0, it technically has access to E index 1 in the memory. If we didn't put those zeros in the matrix, the model would simply look ahead, see the answer is E and copy it. It wouldn't learn any language patterns, it would just learn to cheat. By forcing those weights to be 0, 0, we ensure that token T can only communicate with tokens 0 to T. Okay, hands on building the mask. We need to create a matrix of size tt that looks like this for t equals 3. We will normalize the rows to sum to 1 later, but let's get this shape first. In PyTorch, there's a specific function designed to take a matrix of zeros, and zero out everything above the diagonal, leaving only the lower triangle. Why did it capitalize it so weirdly? Low tree. Wrangle. That reminds me of those cringe shirts, like where it says like she is broken, and then in like bold text, he lied or something like that. I don't know. Just remember me of that. I think there's a subreddit for text like that, but when they get it all wrong and they just produce a gibberish. I don't know. Based on that bold hint, can you guess the name of the PyTorch function? Oh, wait. Oh, you're saying it's low tree. Wait, that would be pretty cool if they actually may manage it. So, torch.lowtree? No, okay. I don't know. Oh, it's PyTorch. Can we do Py? I know it's torch. Try... It's something we try probably. But I'm just gonna say no. No idea. No problem. It's a specific library name, so you either know it or you don't. The function is torch trill. Oh, so we were very close there. It stands for triangle lower. It takes a square matrix and keeps only the bottom left triangle, including the diagonal, setting everything else to 0. Okay. Filling the average matrix. We want to transform our raw x token plus position into a context-aware x. We need to create a weight matrix. Way inside your forward method that looks like this. Start with a matrix of ones. Okay. I don't know where we're gonna do that. Let's do that. I mean, we have the t's here, so maybe do it after pos idx. So torch.ones, so we get matrix of ones, and we want it to have row t and columns of t. And then we do way equals torch.trill way. Wait. Oh, so we're gonna call this a way. That has to be it, right? Otherwise, why would it reference a way? Normalize. Currently the rows sum up to 1, 2, 3. We need them to sum up to 1. So we divide the matrix by its row sums. Multiply this way matrix by your data x using dot product. I'm guessing we're gonna do way x. Wait, way equals way x dot x. Update the for method in master file to include the block before the LM head, like we did here. Here's the logic for the normalization line, as it can be tricky. Oh wait, what did I try to do? Oh, I didn't even do this, did I? I simply skipped ahead. So we do way equals way time divided by way dot sum 1 and keep dim equals true. Is this the case? That looks like a really strong effort. You have successfully built the averaging logic, create the matrix of ones. Yeah. And apply the lower triangular mask, trill. Normalized it so rows sum to 1. So we're dividing it by the sum of itself. How does this work? So we're doing size. Oh, this is the size of the dimensions, okay. And it's one dimension. No, I don't really get that, to be honest. To be frank. However, we have a broken pipe in the data flow right at the end. Let's look closely at these two lines. Way equals weight.x. Logit equals self.lmo. Which variable holds the mixed content aware information and which variable holds the unmixed raw embeddings? Which one are you currently sending to LM head? So we want to send way. Rather, what are we doing with way except if you don't want to use that to create a logit? You connected the pipes correctly. By changing the input of the final layer to way, which now holds the result of the matrix multiplication, you are successfully passing the mixed context-aware information into the prediction head. A quick cleanup tip. While your code works perfectly, way usually stands for weights and the grid of 0.5s, 0.33s, etc. Once you multiply it by the data x, the result is actually the data features, not weights anymore. To avoid confusion later, it's common to just update the variable x itself. Oh. Like so. Let's do it. In previous code. But we still want it the way to be the dot product of x. We can't do x dot way, I don't think. Okay, so you have implemented embeddings, identity, positional encoding, location, self-attention, context via averaging. This is a bag of words model. It's not a full transform yet, but it's much smarter than where we started. So no transforming yet, okay. Go ahead and run masterfile.py. Paste the output here. I'm looking for two things. The loss did it get lower than 0.82, our previous best. The text, is it still stuck in a permanent loop or has the smearing of history broken the cycle? Let's hope it's better than at the start. Because otherwise we've made like 0 actual progress compared to like the last time. Ooh, this is a much better loss. Ooh, okay. So we're getting something. A brain. A rebird in a bran a rebuldrain gibrar in a braden a brain a rebuldrain gaba. I specifically identify with the gaba at the render. Very deep messaging here. I guess we are building a brain. This seems like this is what it takes the most out of. But let's see if we give it this. Let's hear what Gemini thinks of this lesser model's performance. That is a massive improvement. Loss dropped to 0.32, probably 0.82. The model is essentially memorizing your tiny dataset, which is exactly what we want it to do at this stage. Text array, it's clearly trying to write we are building a brain. It has captured the multi-word dependencies. The problem with averaging. We're giving the model memory, but it is a very blunt instrument. By simply averaging past vectors, we are forcing the model to treat every previous character as equally important. In the sentence, the cat, which was Fluffy, sat. To predict on, the model averages cat and Fluffy equally. What sentence? In the cat, which was Fluffy, sat ... To predict on, the model averages cat and Fluffy equally. Why? But cat is the subject. It should be way more important than Fluffy for predicting the verb or location. Right now your weights matrix is static. It looks the same for every single batch and every single sentence. We want these weights to be dynamic. We want token 4 to say, I find token 1 very interesting, but token 2 is boring. The search engine analogy. To fix this, we're going to implement self-attention. This is the heart of the transformer. Think of how you use a library or search a Think of how you use a library or a search engine. Query Q. You ask a question, what am I looking for? Key K. Every book has a label / title. What do I contain? Value V. If the key matches the query, you get the actual content, the value. In our model, every single character will produce these 3 vectors. Query, I am a vowel. I am looking for a consonant. Key, I am a consonant. Value, here is my feature vector. So the character will be... Wait. Yeah, so this is the ID, so to speak, and this is the target, and this is the vector, probably. When a query and a key align mathematically, the attention score goes up. Hands-on. Defining the heads. We need to create 3 new linear layers in init to generate these vectors. They will map our input size, number of embedding dimensions to a new size. Head size. Oh, I do remember this, writing this with ChatGPT for some reason. I really never understood why. Okay, so let's define a head size of 16. Your task, update init to include 3 new linear layers. Self.key, self.query, self.value. Each one should be a NN linear of the number of embedding dimensions for the batch size and head size for the time. Bias false. Note, we usually turn off bias for these layers in simple attention. What does the bias actually do? Like, what's the difference between a bias on or off, slash false and true? True and false. It is very easy to just copy-paste bias false without questioning why. To understand bias, let's look at a simple last equation for a line. Y equals mx plus b. Mx, the weight. This part controls the angle or rotation of the line. B, the bias. This part controls the position the y-intercepts. It allows the line to shift up or down. I guess that makes sense. Without bias, bias false. If you remove b, the equation becomes just y equals mx. This places a strict constraint on the model. The line must pass through the origin 0, 0. If the input is 0, the output must be 0. The model can rotate the data, but it cannot shift it. With bias to true, the model learns an extra number, the b. That it adds to every result. This allows the line to float off the origin. It gives the neuron a default value or a base rate to fire at, even if the input is 0. Okay. Why turn it off for attention? In self-attention we are calculating the similarity between 2 vectors, query and key, using a dot product. So the score becomes the query times the key. We generally want this to be a pure measurement how well they align. If we add bias, we are essentially adding a static background noise to every single calculation. Oh, I see. While some fancy models do use bias in attention, for a basic transformer we usually want the raw geometric relationship between the vectors without any artificial offsets. Does that distinction make sense? If so, go ahead and add those 3 bias false layers to your init. Alright. So, in the init here, we want to add a self.key. Set that to nn.linear of the n embedding dimensions and the head size, and with bias false. Ooh, we also need to create head size. Do we do that in here? Should I define head size as a parameter for the init method and default it to 16, or should I create it in the global scope? I think that's how we call it, the global scope. Like we have block size here. My guess is that we're gonna do it here, but I don't know. Head size. That's my guess. It's a fantastic design question. You're thinking like a software engineer, not just a script writer. Both approaches will technically work, but they have different implications of how robust your code is. Let's look at the pros and cons. Global variable is super easy to access anywhere, but if you import this class into another file, or we want to create two models with different head sizes side by side, the global variable locks you into one choice for everything. Parameter, it makes the class self-contained. You can spin up model small without defining a global variable. Okay, never mind then. Never mind. So we do want it here. So head size int 16. And what did it have? Self. We had key. We also had something else. Query, right? Query, and then dot linear and embed and head size and bias false. So same with self dot value. And then dot linear, number of embedding dimensions, and the head size for the t dimension, and with a false bias. Let's see what it thinks about this. That looks excellent. You chose the robust engineering approach by adding head size as a parameter. This gives you full control over the model's architecture. Now that we have the layers, let's put them to work in the forward method to replace our static average with dynamic attention. Okay. So the attention mechanism, we want to calculate the new way matrix that isn't just ones and zeros, but contains the similarity scores between tokens. The core formula for this affinity score between a query Q and a key K is a dot product. If the vectors point in the same direction, the dot product is high attention. If they are perpendicular, the dot product is 0. No attention. So perpendicular, that means there are different, like opposite directions, right? I think so. Though I am guessing, but I think that's what it means. Well, y equals q times kt. So query times... Wait, is it the key to the power of t or The T stands for transpose, meaning we flip the key matrix so the dimensions align for multiplication. Weird, but okay. Inside your forward method, right after you calculate the X tokens plus position embeddings, we need to generate our keys and queries. Add lines to calculate K and Q by passing X through your new layers. Okay. So do we do it before we do? Yeah, of course, before we do the way stuff, right? Because that's not weighted right now. So K equals self.key, X and Q equals self.query, X. Question: if X has the shape B, T, and number D, batch time channels, and we pass it through a linear layer that outputs head size, what will the new shape of K and Q be? B, T, and B. I'm still so bad at calculating stuff like that. Answer to your question, I have no idea how to even calculate that. I'm honestly just trudging. How do you spell trudging? Trudging along, half understanding the various matrices and their BTC dimensions and the various broadcasting and stuffs. How would I even know what a complex 3D tensor would look like when passed through a linear NN layer? I'm curious about its answer to this. If it's gonna go spout off a lot of basic information, or if it's like gonna go, oh, alright, that's fine, let's just move on. It's completely normal to feel that way. Dealing with 3D tensor batch time channels is one of the steepest learning curves in deep learning. It feels like mental gymnastics because we can't easily visualize 3D grids of numbers changing shape. Let's simplify it with a golden rule that will save you a lot of headaches. I already have a headache, so that would be great. The golden rule of nn.linear. Here's a secret. nn.linear only cares about the very last dimension. It treats the other dimension, batch B and time t, just as stuff to organize. It doesn't touch them. The analogy: imagine you have a crate batch containing 8 boxes. Time. Isn't a crate just a larger box? Well, okay. Let's go with that analogy anyways. Inside each box is a collection of 32 colored marbles. Channels / embeddings. The task: you have machine the linear layer that swaps 32 marbles for 16 coins. The process: the machine reaches into the first box, swaps the marbles for coins, then the second box, and the next crate, Oh, after we've gone all the boxes, then it goes to the next crate or the next batch. Okay. You still have the same number of crates, batch, and boxes time, only the content channels have changed. Okay, so tracing the numbers, let's look at your specific variables. Input x shape b time input x shape b t n embed d, or number of embedding dimensions. So we have 32 batches, 8 time, and 32 channels. The layer, and then that linear in features 32, out features 16. When you pass x through this layer, PyTorch looks at the last number 32. Does it match in feature? Yes. It transformed that 32 into 16. It leaves 32 and 8 part alone. So 32, 8, 32 becomes 32, 8, 16. Now that we know the input shape BT32 gets transformed into BT16, if you write the code k self key x, what will the dimension of k be? Wait, is x 32, 8? It is that, right? Because we have a batch size of 32 and we have a block size of 8. Alright. It is a bit weird to have the block size as a global variable when we didn't do head size as a global variable. But then we do, and 32 was the channels, or the, where do we have it? Here, number of embedding dimensions 32. And since we're setting the head to 16, then we're creating a 32, 8, 32, no, 32, 8, 16 for the K. So K equals 32, 8, 16. Right, the linear layer projects the data into our new head size of 16, but keep the batch B32 and time T8 structure intact. Now we have query Q 32816, key K 32816, calculating affinities. Now we want to calculate these scores. We want to know how much token 4 query cares about token 2 key. We do this by taking the dot product of the vectors in matrix land. We want to multiply Q by K. However, looking at the shapes, we have a mismatch for standard matrix multiplication. We do. That looks fine to me. Why is that a mismatch? To get our desired 32, 8, 8 grid of scores, where every token T has a score for every other token T. Why do we need a... this doesn't make anything easier. To fix this, we need to transpose flip the last two dimensions of K, so it becomes 32, 16, 8. Why did it add weird signs like that? That's weird. Do I need to manually remove them? Why? Why did it do it like that? Okay. Strange. How come the desired shape of the matrix, don't even know what to call this matrix, is let's see, C equals 8. That's latex to make it pretty. Latex? Latex? What do you mean latex? Ompe Policio. Hello, hello, hello. What the hell do you mean with latex? You're just coming out of nowhere making things very sus. I'm so confused. That's the perfect question to ask. When dimensions start swapping, it's easy to lose track of what numbers actually mean. Let's clear up the 8 mystery. What is a matrix? What is this matrix? We usually call this attention scores or affinity matrix. Think of it as a grid of relationships. We have 8 tokens in our sequence. Let's say indices 0 through 8. Every single token acts as an observer query. Every single token also acts as a target key. Why is the last dimension 8? The last dimension isn't channels C anymore, it's actually time T again. Imagine our 8 tokens are students in a classroom. We want to know how much student number 4 is paying attention to every other student. Okay, student looks at student 0, okay, blah blah, score, okay. To store all these relationships for one student we need 8 numbers. Since we have 8 students doing the looking, we need 8 times 8 grid. So the shape 3288 essentially means 32 batches, classrooms, 8 rows, students doing looking, columns, students being looked at. Do you say latex? Latex, not latex, latex. Makes advanced math notation. Many LLM GUIs, graphical user interfaces, support it now, as well as markdown formatting. I can only comment on what I know, so I've been quiet. But you know something I don't know. Latex. Where did you even hear about that? It is latex, but yes, but I call it latex anyways. Yeah. Latex. Imagine hearing someone saying like they're using latex to train their AIs. I mean, like, someone who doesn't know what the hell is going on, they're gonna be like, you do what, man? What did you say your job was? You use latex to train AIs. I'm not gonna judge, but okay, that sounds fascinating. Are you still working on like your translation? Do you call it a bot? Is that what you say? A translation bot? No, not a software probably. Yeah, translation software. Are you still working on that? I watched a streamer code latex for their thesis paper like a decade ago, and I was like, what is that language that writes math PDFs? What? 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 An on-screen translator. Ooh. Fancy. Is it just for like that? What did you call it? Chatterino or something? Is it for that application, or is it for like is it a browser extension, or is it like a third-party like application that you run and that hooks onto like your screen or something? No, like I can almost grab code blocks with my OCR, so it's well tuned. Oh my god, OCR. What does that stand for? I want to say original content reader, but that can't be it. Then live translates any text into tiny text right below it in the margins. Optical character recognition. It was originally made to convert books to text files. So you can pass like a bunch of library books through an OCR and then maybe not you can't, maybe you can't use OCR like that in a sentence, I don't know. I recognize it from somewhere, but it might actually stand for something else also, so I don't know. But it can work with on-screen text if you're good enough. Why did you create that? Yeah, you OCR it. Okay. Why did you create it? Was it like simply a hobby project, or do you plan like on publishing it? I don't know if I asked this question before. Where did 16 go? When we do the dot product between query vector of size 16 and key vector size 16, the result is a single number, a scalar. We spend 16 dimensions to calculate the singularity, so they disappear, leaving us with just the raw scores in that 8x8 grid. Okay, that is fascinating, even though I understand maybe half of it. It is absolutely fascinating. Because then I can translate all words on screen or just grab them. I've always wanted a OCR that powerful. I've been trying for decades. Damn. I mean, that would be really useful. Because I mean, like something like the Chrome browser or whatever, you can set that to like translate all the text on website you visit, like your own language. But that doesn't work for like videos and stuff like that. Or subtitles or whatever. So it would be pretty neat to have like a universal application that did that on your whole PC for all applications and everything. But I can see it being very difficult to figure out. To both make it lean enough to be resource, like, not too intensive on the resources, but still useful and not where it makes mistakes all the time. I can just imagine you like sitting on your Linux PC, like getting everything translated perfectly, like video, text. I don't know, maybe you could even do like image translation, like if there's an image and you also have like text on the image, then get a I don't know, an annotation below or something like that with like the translated text, or maybe like, I guess in real time, like editing an image to make that text translated but still looking alright would be too heavy. Like then you'd probably need like a data center to run the program, but yeah, I always wanted to grab streamers code. Well, it's extremely low resource because I don't use the AI ones. I use Okrad. Oh, you want to steal all of this gibberish? Okay. Wanna copy and paste all my secrets? Nice, kidding. Why do we want streamers code? Are there like specific streamers that you like follow, that program things you're really interested in doing yourself and you want to like have their work on hand to reference, or what do we want to do with the here? We want to you write a line for way using transpose and matrix multiplication of dot product. I don't know. Can we do that? I mean, we could do... Wait, do we want to set way to equal to q at the dot product dot on k dot transpose -2 and 1? Or -1, I mean. So we get the C and the T channels. Wait, the T and the C channels, I mean. But then we will entirely negate all of this way calculation we do up here. I just want to save it for later learning, yes, and this should make it way more clear why it's cool. Imgur is temporarily over capacity. Please try again later. Well, that's the first time I've seen that happen. How many images did you upload, really? To crash your whole website. This can't be right. Alright. Nope. What if I go to Imgur? It is weird that you're even able to produce links if Imgur is over capacity. Oh wait, maybe it's like your IP is allowed as long as you're like on their website, maybe. So if you were to like close everything down and then wait and maybe try to access Imgur again, then it wouldn't allow you to. Maybe. Weird. You're absolutely right to be suspicious. Your intuition is serving you well. You successfully written self-attention logic q .k, but it's currently clashing with the old averaging logic we wrote earlier. Let's look at 3 specific issues in this code snippet. The override, you spend lines creating a nice masked way at the top, but then the line way completely deletes it and replaces it with new raw attention scores. This means the masking is gone and the model can cheat by looking at the future again. The values, you added self value to your init, but you aren't using it here. You are calculating way. Oh, which means you're aggregating the raw token features rather than specific values, the tokens we want to communicate. The probabilities, the math q.k outputs raw scores logits, which can be anything. For the weighted average to work, these need to be probabilities that sum to 1. But I can only make like 1 picture per week. What? No. That can't be right. There's no way that's right. If you want to, you can just add me on Discord. Send me a picture that way. I can try the link one more time, though. One more time. See if something has happened. No. Weird. Let's rewrite your middle section. The middle section of your forward method. First, the value vector the value vector just like you created k and q, add a line to create v using your self value layer. Oh yeah, so v equals self.value x. Makes sense that we want that here. Second, the masking logic, we can't just multiply by a 0 mask anymore because we are dealing with logits. If we want softmax to output a 0, meaning ignore this, the input score needs to be a negative infinity. We typically do this with masked fill. Ooh, this is some other... Ooh, here we have something. Okay, so I can't zoom in for some reason on this website. That's annoying. I can only do it like that. Okay, I'm gonna try to see whatever is going on here. Open, oh yeah. True. True. So it's translating from German. Deutsch. Explain what an elephant is, but in German. So here is one of the explanations what one elephant is up German. I have the text in clear sections divided with the lighter to read is. That elephant, one elephant is that Gert, today living land mammals the earth. He is known for his enormous green, his intelligence, and the question complex, social behavior. It has per word mode and per line paragraph mode. Per word mode better for learning. When you say learning, are you saying like it can learn like an AI model, like a neural network? Or how does it learn? Here by mode word line, okay. Font size. Overlay placement. And using the word mode here. Like learning what the words in German translate over to in English. Oh. For you, okay. Interesting. I want to learn Chinese. So something like that would be pretty useful, I guess. Though I'd also have to start browsing some Chinese websites, I guess. Though... yeah, because I was thinking about if I were to go to Bilibili or something like that, then I'd simply do like the translate function, included in the browser, to translate all the text. But I can see how that isn't conducive to learning at all. Because then, without like the original text to compare to, there's like nothing to learn or whatever. But longer line mode has better contextual translations. I can see that. Especially with German, they have a whole different like grammatical structure, so I can see why that's quite confusing when like converted to English by like word by word. The translator is AI and can hallucinate with single word input sometimes. Well, sometimes is better than always. So yeah. It is kind of crazy, like, that Microsoft hasn't created something like this, like something like you're creating now. Like $1 billion or $1 trillion company now. Like, or are they $1 trillion company? I don't know, but very large company and they want to push AI onto everything, so why not have like an auto translate for everything like you do on your PC? That would have been like an actual useful use case of AI, but for some reason they haven't done that as far as I'm aware. They just want to push AI into Notepad and stuff like that. Man, I hate Windows. I wish there weren't applications on Windows that I really need. Then I'd go back to Linux in a heartbeat. But it looks like Winboat is getting pretty good. So maybe sometime next year I can switch back and still have my applications running. Who knows? The OCR is honestly quite difficult. That's why AI image input was so revolutionary. It's the best OCR, but you need huge video cards. Yeah. Yeah, it needs to be affordable as well. And that is very important. We can't all be like PewDiePie, building your own like AI supercomputer in your basement. Hey. Honestly, I think this is gonna have to be it for today. I've been working on this for 4 hours now. Wait, really? 4 hours? That's more than I thought. But yes, any time then that, yeah. It's been 4 hours already, okay. Oh. My head certainly agrees with that timer, but well, even though it's been very complex, I've had fun today. I'm probably gonna do more programming on this on Sunday. Yeah, on Sunday. Tomorrow is gonna be Hollow Knight Path of Pain, amongst other things. But that's my planned schedule at least. So yeah. Thank you so much for watching. And I hope I'll see you there on Sunday on Papolicio. You take care. I'll see you in the next one. Cheers.